Hello friends, in this session we are going to discuss the simplex stop and wait protocol from the data link layer. So the basic function of this protocol is to achieve flow control, and as we had discussed the categorization in the previous session, it comes under the feedback based method. That is, the sender waits for a feedback before sending the next frame to the receiver. So sender, what happens in this situation is sender sends a frame, it waits for the receiver to give a feedback, and after it receives that feedback, only after that it starts preparing the next frame, and then after that it sends that frame. So the sender, brief idea I have already given you. Sender sends one frame, then waits for an acknowledgement before proceeding to the next frame. So what do I mean by simplex? I said simplex stop and wait protocol. Simplex means that data is transferring only in one direction. It is moving only in one direction. What is that direction? That direction is sender to receiver. So data is always moving in this direction. So then you would say, what is this? There is an acknowledgement from this to this side. So you should all know that acknowledgement is not any type of data. It is just a feedback, right? So, but it will be in the form of a frame. So we say that frames travel in both the directions, but data transfers is only in one direction from sender to receiver, right? So next we have a huge bunch of numericals under this stop and wait protocol, which come under GATE and many other competitive exams. So first of all, we are going to discuss the important formulas under this category, and since they are very simple, so I'll just discuss the basic formation of those formulas, right? So this, I have taken an example scenario that the sender is sending frame F0 from sender is sending a frame F0 to the receiver, then it receives an acknowledgement. Right? This is a very, very basic version. So please don't go into the details that why the timer is not there and so on. So this is a very simple form of a scenario in which the sender is sending a frame to the receiver, then the receiver sends acknowledgement 1. Now that 1 basically means that you need to send me the frame 1 now. I have received F0, that is done. So since it is acknowledgement, if the frame would have not been received correctly, it would have sent a negative acknowledgement. Okay. So for now, just it sends acknowledgement 1. Please send me frame 1. Then he sends frame 1, and then it says acknowledgement 2. Send me frame 2, and it goes so on. So in the same scenario, what we say is that the distance between sender and the receiver is d units. So we have d units between the sender and the receiver. So I am now slowly moving towards the numerical. We have sender and the receiver separated by d units of distance. So these are the steps in which the communication is taking place. First step is sender prepares the frame F0 in time tt. This is also called transmission time, therefore tt, and sends it to the receiver. So it sends it to the receiver. Then the receiver, so first it prepares it. So the frame is prepared, right? So let's say I have this frame over here, F0. So this is prepared, right? So but now it has to move towards the receiver, na? So when it will move, what will happen? It will propagate from sender to receiver. So there comes the role of propagation time. It will take some time to move to reach the receiver from the sender, right? So that there comes the role of propagation time. So the preparation was tt. The propagation is tp. And then what happens is, after the frame is received at the receiver end, it sends an acknowledgement. So we take the acknowledgement preparation time of that acknowledgement frame as negligible. We take it as negligible, and we, yes. So it basically, we just take the propagation time of that acknowledgement frame into consideration. Sorry about that. So what will happen is, the total time will be TT plus TP for this frame and another TP for the acknowledgement frame, right? So I should write acknowledgement and then it moves back to the sender. So another TP over here, right? Okay, so the total time is TT plus TP plus TP, which is TT plus 2 TP. So now we just define the various terms which we used. The first one was transmission time. So it is the time taken by the sender to transmit the data into the network. This is done by building it in the form of a frame. So TT is TT is formulated as F by R, where F is the size of the frame, generally measured in bits, and R is the bit rate, right? Bit rate at which it is sent, or bit rate of the channel, which is measured in bits per second. So if we just put the units over here, we'll get that TT has the units as seconds. Also, it is the time. Time is always measured in seconds. So this is transmission time. Then we also talked about signal propagation time. So it is the time taken by the signal to travel, or the frame propagation we can also say. It is the time taken by the signal to travel from sender to receiver in the medium. It is represented by TP, as we have already shown in the diagram previously, and it is equals to, now time is always equals to distance upon speed, right? So distance was d units, speed we had taken as v. So v is the speed of the propagating signal. Speed is measured in meters per second, d is measured in meters, so time again has unit seconds. Finally, we have channel utilization and throughput. So channel utilization, it is the time for which a sender is active or in working state in an entire cycle. So the active time of the sender upon cycle time. Active time was when it prepared the frame, which was TT, and the total time we already calculated, it was TT plus 2P. So if you just divide the units, this is second upon second, the units get cancelled. So this is just a ratio, it does not have any units. Finally, the throughput. Throughput is the actual amount of data transmitted in a cycle. So it is actual data delivered upon time of one cycle. Actual data delivered is the frame size, which is F. Time of one cycle is TT plus 2P, TT plus 2 TP. So frame size was measured in bits. Time is measured in seconds. So the units are bits per second. Right? So that's all for the numerical formulation part. In the next session, we are going to take up a numerical of stop and wait from the GATE previous year papers. So stay tuned and keep working. Active learning, keep working, keep doing your hard work. Thank you.